Hi everybody, we're continuing our discussion of hypothesis testing. Today we're going to be testing a claim about a mean using the TI-84 calculator and the t-test function on the calculator. So what I want to cover in this video is I want to teach you about the process for testing a claim about a population mean, and we're going to be using that process to form a conclusion about a hypothesis test by using the TI-84 t-test function on our calculator. I'm going to go through two examples, one with statistics and one with data. So let's get started. What do we need to know? Well, once again, we're going to need to identify the null hypothesis, the alternative hypothesis. We're going to have to know if the test is left-tailed, right-tailed, or two-tailed. We're going to have to find the p-value and the level of significance. So let's look at an example. So in a sample of 36 cans of Coke, they have a mean volume of 12.19 ounces. And the standard deviation is 0.11 ounces. Use a 0.05 significance level to test a claim that cans of Coke have a mean volume of 12 ounces. Okay, what do we know? So we need to identify the null hypothesis and the alternative hypothesis. We need to identify the sample mean, the sample standard deviation, the number in our sample, if the test is left-tailed, right-tailed, or two-tailed, and the significance level, alpha. Remember that the null hypothesis is the equal sign. So the null hypothesis is that the mean is equal to 12.00 ounces. And so the alternative hypothesis is, since we're testing a claim that the cans of Coke have a mean of 12.00 ounces, that's going to be our original claim. Then the alternative hypothesis is that it isn't equal to 12 ounces. The mean from the sample is 12.19. The standard deviation from the sample is 0.11, and we tested 36 cans of Coke. This test is two-tailed because it's a not equal to, and the significance level was 0.05. We're going to do this on our calculator. This time, since we are doing a test of the mean, an hypothesis test of the mean, we're going to be using the t-test. So the two examples I'm going to use today, or I'm going through, one you're going to use data and one you're going to use statistics. In this example, we have the statistics. So we're going to submit these statistics. The mean that we are testing for is that the mean is equal to 12. The sample mean is 12.19. The sample standard deviation is 0.11. The number in our sample is 36. And this is a two-tailed test. From this test, we see that the p-value is 3.30 times 10 to the negative 12. So remember, that means move the decimal point 12 places to the left. So essentially, that p-value is going to be 0. Since 0 is less than 0.05, p is low, null must go. That means we failed to reject the null hypothesis. So if p is low, null must go. So that means we do reject the null hypothesis, sorry. So the conclusion is to reject the null hypothesis. There is sufficient evidence to warrant rejection of the claim that the mean volume is equal to 12 ounces. Okay, let's go on to another example where we're given data. Students in Mrs. Dunn's class estimate the length of 1 minute without referring to a watch or clock, and the times and seconds are listed below. Use a 0.05 significance level to test the claim that these times are from a population with a mean equal to 60 seconds. So the times are listed here, 69, 81, 39, etc. What do we know? We need to identify the null hypothesis and the alternative hypothesis. Is this test going to be left-tailed, right-tailed, or two-tailed? And what's the level of significance? So we're testing the claim that the students, the population, that the times are from a population with a mean equal to 60 seconds. So that the mean is equal to 60 seconds. That's our original claim. The alternative hypothesis then is that the mean does not equal 60. Remember that null hypothesis is always the equal sign. So this is going to be that the mean is equal to 60. Since the alternative hypothesis is the not equal sign, this is a two-tailed test. And the level of significance is 0.05. Okay, to do this on our calculator, we're going to have to put all this information in our calculator. So you're going to press the Stat key and Edit, and you're going to enter those values into list 1. I've already done that for the sake of time, but feel free to pause the video and input all those values. Remember, I think there's 15 values here. Okay, so make sure you get them all in there. All right, then quit out of there. And the next thing we're going to do is we're going to press Stat, and we're going to compute this test. So toggle over to Test, and we're going to be doing a t-test since we are testing a hypothesis that has to do with the mean. So I'll press Enter, and this time we're putting in data. So the mean that we are testing is whether or not this is equal to 60. So you're going to say that the null mean is 60. We put this information in as a list of data. So that list went into list 1, if you remember. So that's what I'm going to put here. The frequency should stay 1. This is a two-tailed test. And then we'll press Calculate. And the p-value is 0.6043. So the p-value 0.6043 is greater than 0.05. P is high, null must fly. The conclusion, therefore, is there is not sufficient evidence to warrant rejection of the claim that the times are from a population with a mean of 60 seconds. Okay, that's all there is to it. Good luck.